Hi, welcome to the class. Now we will continue our discussion on binding energy. Today's topic is binding energy curve. So in this is a graph. Binding energy curve is a graph, and this is a graph between binding energy per nucleon with mass number, right? And there are few important observations which we have to make from this curve. So the first observation which we have to make is this, that the binding energy per nucleon increases rapidly up to A is equals to 20. So with this is the mass number, so up to 20 it increases rapidly. So this is A is equals to 20. So from 0 it started and it increases rapidly up to A is equals to 20. This is the first observation. Second, as you could see that there are certain peaks. There are these peaks. So these peaks correspond to certain mass number, and these peaks correspond to A is equals to 4, 12, 16 and 20. This is the second observation, that there are certain peaks which correspond to A is equals to 4, 12, 16 and 20, and these have more stable nucleus. These have stable nucleus. So they have more stable nucleus. So this is what they correspond to. Now the most strongly bound nucleus is the iron. As discussed in the previous class also, it has the highest binding energy per nucleon of 8.8 MeV. It has the highest binding energy per nucleon of 8.8 MeV, and therefore it is the most stable. Most stable. In order to break this, we have to provide 8.8 million electron volt to each and every nucleon, and since it has total number of nucleons are 56, so we have to provide a lot of energy, that is 56 into 8.8 MeV. This is what we have to provide, right? Now next is this, that after 56, as we increase the mass number, binding energy per nucleon decreases. So it means the nucleuses which have a greater mass number, greater than 56, it is easier for us to break them apart, and therefore they have lesser binding energy per nucleon. And these nucleus which are there at this point, since they have greater mass number, they have less binding energy per nucleon, and therefore they tend to break off quickly. And if I tell you, these shows nuclear fission. And why do they show nuclear fission? They show nuclear fission because they have greater mass number and therefore lesser binding energy per nucleon, and they easily break off. Whereas for the lesser mass number, they usually don't break off it very easily. This is the moderate, this is the highest. So it means below this we have the lowest, and above this we have the highest. I am talking about the stability. This is the most stable, above it more volatile, less stable, and below it of course less volatile but less stable as well. So these shows nuclear fission because they have greater mass number and hence lesser binding energy. And here they will show nuclear fusion. Nuclear fusion. So they tend to combine because they have lesser binding energy, so they tend to combine. And the ones which has greater binding energy, they tend to break off. Right? So this was the topic, easy one and the simple topic, binding energy per nucleon. So you could check the notes also for this, and that is there, right? Thank you.